Hello everyone. In my previous video, I discussed about the continental drift theory of Professor Wegener. In continuation to that, in this video, I will discuss about the concept of seafloor spreading and the plate tectonics. So let's begin. As you know that Wegener's theory wasn't taken very seriously in the beginning. Especially in USA, the scientists were against this German geographer and his hypothesis. But several post-continental drift studies have revealed many new facts, like the ridges in the ocean floor have been emitting lava actively, like the rocks of the ocean crust are much younger than those of the continents. They are nowhere older than 200 million years, whereas the rocks of the continents are as old as 3,200 million years. There are remarkable similarities in the rocks located equidistant on the either side of the oceanic ridges. This means that the rocks near the mid-oceanic ridges are the youngest and their age increases gradually as we move away from the ridges. Geologists also said that the top of the high peaks of the Himalayas are covered with limestone, which is a type of rock that forms at the bottom of warm shallow sea and is composed of fossilized marine creatures. For years, geologists struggled to explain how the remains of tiny sea creatures could exist at the top of the Himalayan ranges. The concept of seafloor spreading was given by Harry Hess in 1961. He was a geologist and a Navy submarine commander who discovered the mid-Atlantic ridge. Seafloor spreading is a geological process where there is a slow addition of new oceanic crust in the ocean floor through a volcanic activity which adds molten magma while moving the older rocks away from the mid-oceanic ridges. Harry Hess, as a submarine commander, also found out that the temperature near the mid-Atlantic ridge was higher than the surface away from it. He also believed that the high temperature was due to the magma that oozed out from the ridge. Now watch this video. The video shows that how the magma oozes out of the sea floor to form the new crust. So it was then realized that the mid-oceanic ridge is formed where the seafloor spreading occurs, in which tectonic plates split apart from each other. We can say that the seafloor spreading occurs at the diverging plate boundaries. It was also said that the Atlantic Ocean is widening or expanding, and on the other hand, the Pacific Ocean is shrinking. And now, the mid-Atlantic ridge has become the classic example of seafloor spreading. Our next topic is the plate tectonics. This theory says that the entire crust of the earth is divided into 7 major and many minor plates. These plates are moving on a semi-liquid surface called the asthenosphere. These plates are moving independently in different directions. The movement of these plates leads to the building of stress. Some plates move towards each other, some move away from each other, and some slip horizontally past each other. Now let's see these 7 major tectonic plates and some minor plates on the map. First, the North American plate. It spreads over North America and the western half of the Atlantic Ocean up to the mid-Atlantic ridge. Second, the South American plate. It covers the South American continent and up to the mid-Atlantic ridge. Third, the Indo-Australian plate. It is both a continental and oceanic plate and covers most part of India, whole of the Australia and a large part of the Indian Ocean. Fourth, African plate. This is one of the most stable plate and covers whole of the Africa, eastern part of the South Atlantic Ocean and some parts of the Indian Ocean. Fifth, Eurasian plate. It is mostly a continental plate and spreads over large parts of Europe and Asia. Sixth, Antarctic plate. It covers the whole of the Antarctic continent and the surrounding ocean. Last, seventh one, Pacific plate. It is the largest plate and it is the only oceanic plate that covers most part of the Pacific Ocean. Now we will do some of the minor plates. First one, Nazca plate. Nazca plate lies between South America and Pacific plate. Then Caroline. Caroline plate lies between Philippines and Indian plate. It is situated north of New Guyana. Then next, Caribbean plate. It is located between North and South American plate. Next, we have Arabian plate. Most area covered by this plate is between the Saudi Arabian landmass. Next, we have the Philippines plate. It is located between the Eurasian plate and the Pacific plate. Last, we have the Cocos plate. It is located between the Central America and the Pacific plate. Let us do the plate boundaries. There are three types of plates and their boundaries are called plate boundaries. First one, the divergent plate boundaries. The plates which are moving away from each other are called divergent plates and their boundaries are called divergent boundaries. Most of the divergent boundaries are along the mid-oceanic ridges. These plate boundaries are also called constructive boundaries because they help in developing new lands. For example, the mid-Atlantic ridge where both the American plates are separated from the Eurasian and African plates. You can see the pictures of the examples. The African Rift Valley is also one of the big examples of divergent boundary, and the mid-Atlantic ridge you already know is a classic example of plate boundaries. These divergent plate boundaries are also, helping seafloor spreading, as I have already discussed. Next, we will do the convergent boundaries. The plates which move towards each other are called the convergent plates, and the boundaries between the plates are known as the convergent boundaries. I have also mentioned here that they are destructive boundaries. They are destructive because they move towards each other, they dash with each other, so they cause a lot of destruction. These boundaries are of three types. Let us discuss. The first type of convergent plate boundary we will do is the situation when an oceanic plate collides with a continental plate. In this case, the denser oceanic plate is forced below the continental plate. The oceanic plate is forced into the mantle and the rocks melt due to the friction. The molten rocks rise on the surface in the form of volcanic eruptions and the volcanic mountains are formed. Also, the trenches are also formed along the continental edges. A very good example is the Peru-Chile Trench. This trench is formed by the collision of Nazca Oceanic Plate and the South American Continental Plate. The second type of convergent plate boundary is the situation when two continental plates collide and neither of the plate can be forced under because they are of the same density. In such a situation, the sediments are folded and fold mountains are formed. For example, the Himalayas and the Alps have been formed in this way. Himalayas and Alps were formed when the Indo-Australian plate collided with the Eurasian plate. In that case, the fold mountains came up, taking the shape of the Himalayas and the Alps. Now, the third type of plate boundaries are formed in the situation when two oceanic plates converge. In this case, the plate which is older, cooler and denser, that slips beneath the less denser plate. This motion results in the formation of deep trenches. For example, Mariana Trench. This is one of the classic example. Mariana Trench is located in the Pacific Ocean. You can see the situation of the trench on this map and also see this picture of Mariana Trench. Must have seen this Mariana Trench in the movie Life of Pi. Well, after the three types of convergent plate boundaries, we will do the transform plate boundary. When two adjacent plates move horizontally past each other along a fault, such plates are called the transform plates and the boundaries are known as transform boundaries. In this case, plates are neither created nor destroyed. Hence, they are also called conservative boundaries. They are characterized by a number of earthquakes. For example, San Andreas Fault in California is one of the good examples of transform boundary. Now let us see the examples of the plate boundaries on the world map. First is the example of divergent boundary. It is the mid-Atlantic ridge located in the middle of Atlantic Ocean. Second is the example of convergent plate boundary. When an oceanic plate converges with the continental plate. Here, Nazca plate, which is an oceanic plate, converges with the South American plate, which is a continental plate, leading to the formation of Peru-Chile Trench. The third one is again the example of convergent boundary, but here two oceanic plates are converging, and this is Tonga Trench in Pacific Ocean between Indo-Australian plate and the Pacific plate. The last one is the example of transform boundary, that is San Andreas Fault in California between the Pacific plate and the North American plate. Well, by now I believe that the concept of seafloor spreading and the plate tectonics are clear to you all. Thank you.